And now in this lecture we will find out the area of the big circle. In the drawing we have two circles. Those two circles are tangent to each other at this point, point C. Point C is the point of tendency of those two circles with each other. In addition, we know that this is line segment AC, that is equal to 16 units in its length. This is line segment CB, that is equal to 9 units in its length. This is tangent DE, that is tangent to this small circle at point B, and tangent DE is tangent to the big circle at this point. Again, our mission is to find out the area of this big circle. So first of all, we will define the point of tendency of this tangent DE with this big circle. This point is point B, is point M. So, and we focus on this point B in relation to the big circle. Point B is the common extreme point because it is not located inside the circle nor on the circle itself, but it is located outside the big circle, and therefore it is defined as a common extreme point, point B. From this common extreme point B, we have tangent BM, that is tangent to this big circle at point M. In addition, if we draw a straight line, this straight line, it will cut the circle, at the big circle at 2 points, point C and point A. So actually, all the requirements of rule 10 are satisfied, and therefore we can implement a rule 10. So, I'll repeat quickly on rule 10. According to rule 10, rule 10 is true in any circle. In any circle, if AB is any chord in the circle, this is called AB. And PT is the tangent to the circle. This is tangent PT. That is tangent to this circle at point T. So if from the common subpoint point P you draw a straight line and it will cut the circle at 2 points A and B, in this way you create chord AB, and from the same common subpoint point P you draw this tangent PT. So in this drawing the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule 10 in our drawing. Well, because from the common extreme point B, we have here tangent BM, and from the same common extreme point B, if you draw this straight line, it will cut the circle at point C and point A. So all the requirements of rule 10 are satisfied, and therefore according to rule 10, the following equation will be true, that BM square equals to BC times BA. Again, BM square equals to BC times BA. So I write it down. So if we focus on the common point B, according to rule 10, the following equation is true. That BM square, that is the square of tangent BM, is equal to BC times BA. So I'll repeat again. If we focus on the common extreme point B, according to rule 10, the following equation is true, that BM square equals to BC times BA. tangent BM is the missing side, so we leave it as it is. So it is BM square. It is equal to BC times BA. BC is 9 times BA. BA in total equals to 9 plus 16, that is 25. So according to Rule 10, we actually found out that BM squared equals to 9 times 25. Here we take a root out of this equation and we get that BM equals to the square root of 9, that is 3, times the square root of 25, that is 5. So in total, BM equals to 3 times 5, that is 15. So we found out that the length of tangent BM is equal to 15 units. So actually, this is tangent BM, the length of tangent BM is 15 units. So BM equals to 15 units. Point C is the point of tendency of the two circles with each other. So from the point of tendency of the two circles with each other, we will draw a common tangent. And we will define the touching point of this common tangent with this tangent DE, this point is point N. Again, CN, it is actually the common tangent. Tangent CN belongs to the big circle, and tangent CN also belongs to the small circle. It is a common tangent that belongs to both circles. In the next step, we will focus on this common external point, point N. From this common external point, point N, we have two tangents to the small circle, tangent NB and tangent NC. We have tangent AB, tangent NB, and tangent NC. And according to Rule 2, they are equal to each other. That is to say, the length of this tangent NB equals to the length of this tangent NC. So I repeat quickly on Rule 2. According to Rule 2, the lengths of two tangents from a common external point to a circle are equal. In the drawing, we have a circle. This is the common external point, point P. From this common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule, Rule 2, they are equal to each other. That is to say PA equals to PB. So we can implement Rule 2 in our drawing. From the common external point, point N, we have two tangents to the small circle, tangent NC and tangent NB. According to Rule 2, they are equal to each other. That is to say, NC equals to NB. So I write it down. NC equals to NB according to Rule 2. In the next step, we will focus on this triangle CNB. On this triangle CNB, side CN equals to side NB. So I'll copy triangle CNB in a new page. Okay, this is diagram C and B that I copied from the original drawing. According to rule 2, Cn equals to Nb. Cn equals to Nb. And we have the rule that says that in front of equal sides in the triangle, there are equal angles. So in front of this side Cn, we have angle CBN, and in front of this side NB, we have this angle, that is angle NCB. So because of the fact that those two angles are located in front of those two equal sides, they must be equal to each other. So if we define the size of this angle as alpha, then this angle must be also equal to alpha because they are equal to each other according to the rule that I mentioned. Okay, so we actually found out that in triangle NCB, this angle equals to alpha, and this angle also equals to alpha. In the next step, we will join point C and M together by a straight line. Point M is the point of tendency of tangent DE with the big circle. And we focus again on the current standpoint, point N. From this current standpoint, point N, we have two tangents to the big circle, tangent NM and tangent NC. And according to rule 2, they are equal to each other. That is to say, NM equals to NC, NM equals to NC according to rule 2. Tangent NM equals to tangent NC. So I'll copy triangle NCM in a new page. This is actually triangle NCM. So actually, this is triangle C and M that I copied from the original drawing. According to rule 2, Cn equals to Nm. Again, I write it down. Cn equals to Nm according to rule 2. So in front of those two equal sides in triangle C and M, we have equal angles. In front of this side M and we have this angle, and in front of this side CN we have this angle, angle NMC. So according to the rule that I mentioned, those two angles are equal to each other because of the fact that they are located in front of those two equal sides. So if we define the size of this angle as beta, then this angle must be also equal to beta because they are equal to each other according to the rule that I mentioned, that in front of equal sides in the triangle there are equal angles. So if I found out that angle MCN equals to beta, this is angle MCN that is equal to beta, and angle CMN also equals to beta. In the next step, I'll copy the big triangle CMN that consists of those small two small triangles, triangle CMN and triangle CBN. In a new page, And we will analyze this big triangle, triangle CMB. The big triangle CMB. Actually, this is the big triangle CMB that I call it from the original drawing. So we know that the sum of the angles in any triangle is equal to 180 degrees. It is true in any triangle, and especially it is true in this triangle, triangle CMB. Okay, so in triangle CMB, the sum of its angles must be equal to 180 degrees. So actually, this is angle beta, plus this is angle alpha plus beta, plus this is angle alpha. In total, they must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles in any triangle is equal to 180 degrees. So, which angles we have in this side of the equation? We have beta plus beta is 2 beta, alpha plus alpha is 2 alpha, and it is equal to 180 degrees according to the rule that I mentioned. So actually found out that 2 beta plus 2 alpha equals to 180 degrees. Here we will divide this equation by 2, and finally we get that alpha plus beta equals to 90 degrees. So actually this is angle alpha plus beta, the big angle alpha plus beta. This angle is a right angle. This is the big angle alpha plus beta, and the big angle alpha plus beta is a right angle. So this is a right angle. So actually, the big angle is angle NCB. Again, the big angle is angle MCB, and the size of the big angle MCB is 90 degrees. Okay. Again, the size of the big angle MCB is equal to 90 degrees. Okay, so AB, according to what is given us the question, AB is a straight line. So AB is a straight line. If we focus on the left side of the straight line AB at point C, here the sum of the angles must be equal to 180 degrees according to rule 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have the straight line AB. This is angle alpha, this is angle beta. So the sum of the angles on one side of this straight line AB is equal to 180 degrees. That is to say, the sum of the angles on the upper side of the straight line AB is equal to 180 degrees. Which angles we have at the upper side of AB? We have angle alpha and angle beta. So the sum of the angles on the upper side of AB at point Q, it must be at specific point. The sum of the angles on the upper side of the straight line AB at point Q is equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle alpha and this is angle beta. So in total, alpha plus beta, that is the sum of the angles on the upper side of AB at point Q, is equal to 180 degrees. So we can implement rule 3 on the straight line AB, on the left side of the straight line AB at point C. So which angles we have on the left side of the straight line AB at point C here? We have this angle that is a right angle plus this missing angle. In total, they must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we will join points A and M together by a straight line. And we'll focus on the big circle. On the big circle, we have a peripheral angle ACM. This is peripheral angle ACM, and we just right now found out that angle ACM is a right angle. So peripheral angle ACM that is located inside this big circle is equal to 90 degrees in its size. So here we can implement rule 5. I will click quickly on rule 5. According to rule 5, any peripheral angle that is equal to 90 degrees must subtend on the diameter of the circle. So in the moment we have a circle, and this is peripheral angle MAN. This peripheral angle MAN is a right angle. And according to this rule 5, whenever you have a peripheral angle that is a right angle, then this peripheral angle must subtend on the diameter of the circle. That is to say, MN is the diameter of the circle. Again, because of the fact that this is peripheral angle MAN, this is right angle, this peripheral angle MAN must subtend on the diameter of the circle. That is to say, MN is the diameter of the circle. Okay, so can you implement rule 5 in our drawing? Why? Because in our drawing we have peripheral angle ACM that is a right angle, and therefore peripheral angle ACM must subtend on the diameter of the circle. That is to say, and we can say that peripheral angle ACM subtend on AM, and therefore AM is the diameter of the circle. So already know, we actually found out that according to rule 5, AM is the diameter of the circle. Then again, according to rule 5, AM is the diameter of the circle because of the fact that peripheral angle ACM subtend on AM, and peripheral angle ACM is a right angle. So we know that the center of the circle must pass, or the diameter of any circle passes through the center of the circle. That is to say, the center of the circle must be located on AM, that is the diameter of the circle. Again, the center of any circle must pass through the diameter of the circle, and the diameter is AM, therefore the center of this circle must be located on AM, that is the diameter of the circle. So, therefore, this is point O that is located on AM. So point O is the center of this circle. Point M is the point of the circle itself. Therefore, this is exactly the definition of a radius. Therefore, OM is the radius of this circle. So we define the radius of this circle as R, or M equals to R. And because of the fact that the radius OM of this big circle is drawn to point M, that is the point of tendency of tangent DE with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent DE will be perpendicular to the radius MO. If DE is perpendicular to MO, it means that this angle equals to 90 degrees. And and this angle also equals to 90 degrees according to rule 1. So, in the next step, we will implement the Pythagoras theorem on this right big triangle, triangle A and B. So, I'll copy the right triangle A and B in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle A and B. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. According to rule 10, MB equals to 15 units in its length. The hypotenuse AB in total equals to 16 plus 9, that is 25. AM is the missing side, so we'll find out the length of the missing side AM by implementing the Pythagoras theorem on this right triangle, triangle A and B. So here by PT is the derivation from Pythagoras theorem. So actually, this is the right big triangle, triangle A and B that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle A and B, AB squared, that is the square of the hypotenuse, equals to AM squared plus MB squared. So I'll write it down. So AB squared, that is the square of the hypotenuse, is equal to AM squared plus MB squared. AB is 25, therefore AB squared is 25 squared, that is 625, and it is equal to AM squared. AM is the missing side, so we leave it as it is, plus MB squared. MB is 15, therefore MB squared is 15 squared, that is 225. So in total, we found out that according to the Pythagoras theorem, in this right triangle A and B, 625 equals to AM squared plus 225. Here we'll subtract 225 from this equation, and we get that 625 minus 225 is 400. So 400 equals to AM squared. Here we take a root out of this equation and finally get that AM, the missing side AM, equals to the square root of 400, that is 20. So AM equals to 20 units in its length. AM, we already found out that AM is the diameter of the big circle. According to rule 5, AM is the diameter of this big circle. So the diameter AM over 2 is the radius of the big circle. Okay, so AM is 20, 20 over 2 is 10. So we found out that the radius of the big circle is equal to 10 units in its length. Our mission is to find out the area of this big circle. Actually, we know that the area of any circle, is equal to pi times the radius of the circle squared. Repeat again. The area of any circle equals to pi times the radius of the circle squared. And therefore, the area of the big circle must be equal to pi times the radius of the big circle squared. We just right now found out that the radius of the big circle r equals to 10, and therefore the radius squared is 10 squared. So in total, we found out that the radius that we are looking for in this question, the radius of the big circle, equals to pi times 10 squared. 10 squared is 100, so in total this expression equals to 100 pi. 100 pi is 314.159 square units. And that is the answer to the question. So if we found out that the area that we are looking for in this question, that is the area of this big circle, it is equal to either 100 pi square units, or in terms of numbers, it is equal to 314.159 square units. So in the next step, I'm summarize the lecture. So in this lecture, our mission is to find out the area of this big circle. So in the drawing, we have two circles, and those two circles, and they are tangent to each other at this point, point C. In addition, we have also tangent DE, that is tangent to this small circle at point B. Tangent DE is also tangent to this big circle at point M. We also know that this is line segment AC. We can relate to it as chord AC. This is a chord in the big circle that is equal to 16 units in its length. This is line segment CB. Line segment CB can be related also as a chord in the small circle. And the length of chord CB or line segment CB is 9 units. Again, our mission is to find out the area of this big circle. So first of all, if we focus on this common standpoint, point B is a common standpoint in relation to this big circle. So from this common standpoint, point B, we have tangent BM that is tangent to this big circle at point M. And from the same common standpoint, point B, if we draw this straight line, it will cut the big circle at 2 points, C and A. In this way, we created here chord CA. So actually, all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, the following equation is true: that BM squared equals to BC times BA. Again, BM squared equals to BC times BA. So repeat again. If we focus on the common standpoint, point B, according to rule 10, the following equation is true: that BM squared equals to BC times BA. Tangent BM is the missing tangent, so we limit as it is, so it is BM squared, that is equals to BC. BC is 9 times BA. BA in total equals to 16 plus 9, that is 25. Again, according to rule 10, BM squared equals to BC times BA. BC is 9, BA is 25. So BM squared equals to 9 times 25. Here we took a root out of this equation and finally found out that BM equals to the square root of 9, that is 3, times the square root of 25, that is 5. So in total, BM equals to 3 times 5, that is 15. So we found out that the length of this tangent BM is equal to 15 units. Okay. In the next step, we did a construction. That is to say, from this from the point of tendency, this point of tendency, point C is the point of tendency. That is to say, those two circles are tangent to each other at this point, point C. That is to say, they touch each other at point C. So we actually draw tangent CN. That is a common tangent. Actually, tangent CN belongs to both circles. Tangent CN is a tangent to the big circle, and tangent CN is also tangent to this small circle. So CN is a common tangent that belongs to both circles. So here we can implement rule 2. Why? Because if you focus on this common extent point N, from this common extent point N, we have two tangents to this circle, tangent NB and tangent NC. And according to rule 2, they are equal to each other. That is to say, NB equals to NC. Okay, NB equals to NC. According to rule 2, NB equals to tangent NB equals to tangent NC. So, in the next step, I copied this triangle C and B in a new page and analyze this triangle C and B. Okay, this is triangle C and B that according to the audio domain. According to rule 2, Cn equals to NB. And we have the rule that said that in front of equal sides in the triangle there are equal angles. In front of this side Cn, we have this angle CBN. In front of this side NB, we have this angle NCB. So, because of the fact that those two angles are located in front of those two equal sides, they must be equal also to each other. So, if we define the size of this angle as alpha, then this angle must be also equal to alpha because they are equal to each other according to the rule that I mentioned. Okay? So, those two angles, they are both equal to alpha. Okay, so in the next step, we join point C and M together by straight line. And we continue to focus on this common extent point N. From this common extent point N, we have two tangents to the big circle, tangent NC and tangent NM. And according to rule 2, they are equal to each other. That is to say, NC equals to NB. Okay, NC equals to NB according to rule 2. In the next step, I copied this triangle C and M in a new page and analyze this triangle C and M. So actually, this is triangle C and M that I copied from the original domain. According to rule 2, Cn equals to NB. Cn equals to NM. Again, Cn equals to NM according to rule 2. And according to the rule that states that in front of equal sides in the triangle there are equal angles. So in front of this side NC, we have this angle CMN. In front of this in front of this side NM, we have this angle that is angle MCN. And because of the fact that those two angles are both located in front of those two equal sides, they must be equal to each other. So if the size of this angle is beta, then the size of this angle must be also equal to beta, according to the rule that I mentioned. So actually found out that those two angles are both equal to beta. In the next step, I copied the big triangle MCB in a new page and analyze this triangle MCB. So actually, this is the big triangle CMB that I copied from the original drawing. Angle MCB equals to alpha plus beta. Angle CMB equals to beta. And this is angle CBM that is equal to alpha. According to the rule that the sum of the angles in any triangle is equal to 180 degrees, it is true in any triangle, and especially it is true in this triangle MCB. So the sum of the angles in this triangle MCB must be equal to 180 degrees. That is to say, angle beta plus this is angle alpha plus beta plus this angle alpha, in total they must be equal to 180 degrees. Beta plus alpha plus beta, or alpha this is angle alpha plus beta plus this angle beta plus this angle alpha. In total, the sum of those two angles must be equal to 180 degrees. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. So, in this side of the equation, we have in total 2 beta plus 2 alpha, that is equal to 180 degrees. 2 beta plus 2 alpha equals to 180 degrees. Here we divided this equation by 2, and finally found out that alpha plus beta equals to 180 degrees over 2 is 90 degrees. So if we found out that this is angle alpha plus beta, and according to what we just found out that alpha plus beta, it is a right angle. The big angle alpha plus beta, it is a right angle. So this is a right angle, or angle NCB is a right angle. We know that AB is a straight line according to what is given as the question. So if you focus on the left side of the straight line AB at point C, here the sum of the angles must be equal to 180 degrees according to the rule 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of AB at point C? We have this angle that is the right angle plus this missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. So this is angle ACM, that is a right angle. In the next step, we join points A and M together by a straight line. And we'll focus on the big circle. Inside this big circle, we have peripheral angle ACM. This is peripheral angle ACM, and peripheral angle ACM is a right angle. And according to rule 5, any peripheral angle that is a right angle must subtend on the diameter of the circle. That is to say, this is peripheral angle ACM, that is a right angle. This peripheral angle ACM must subtend on the diameter of the circle. Peripheral angle ACM subtend on AM, and therefore AM must be the diameter of the circle. Again, according to rule 5, AM must be the diameter of the circle because peripheral angle ACM is a right angle, and any peripheral angle that is a right angle must subtend on the diameter of the circle. Therefore, AM is the diameter of the circle. So according to rule 5, AM is the diameter of the circle. So AM is the diameter of the circle. We know that the center of the circle, the center of any circle must be located on the diameter of the circle. Again, the center of any circle must be located on the diameter of the circle. That is to say, the center of this circle must be located on AM, that is the diameter of the circle. So this is point O, that we define the center of the circle, and point O is definitely located on AM, that is the diameter of the circle. Point O is the center of the circle, point M is the point on the circle itself, therefore OM is the radius of this circle. We define the radius of this circle as R. Because of the fact that the radius OM is drawn to point M, that is the point of tendency of tangent DE with this circle, and whenever your radius that is drawn to the point of tendency, then tangent DE will be perpendicular to the radius MO. If DE is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, I copied this big triangle A and B in a new page, and we implemented the Pythagoras theorem on this big right triangle A and B. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is the right triangle A and B that I copied from the original drawing. The hypotenuse AB is 16 plus 9, that is 25. MB equals to 15 according to rule 10. AM is the missing side. So according to the Pythagoras theorem, this right triangle A and B, AB squared, that is the square of the hypotenuse, equals to AM squared plus MB squared. AB is 25, therefore AB squared is 25 squared, that is 625, and it is equal to AM squared. AM is the missing side, so we leave it as it is, plus MB squared. MB is 15, therefore MB squared is 15 squared, that is 225. So in conclusion, we shall find out that 625 equals to AM squared plus 225. Here we subtract 225 from this equation, and we found out that 625 minus 225 is 400, so 400 equals to AM squared. Here we took a root out of this equation and found out that AM equals to the square root of 400, that is 20. So AM equals to 20 units in its length. But AM is the diameter of the circle. That is to say, the diameter of the big circle is equal to 20 units in its length. And we also know that the diameter that is divided by 2 is the radius of this big circle. Oh, okay. So here, the diameter AM, if we divide it by 2, we get the radius R. AM is 20, so 20 over 2 is 10. So we can find out that the radius of this big circle is equal to 10 units in itself. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Repeat again, the area of any circle is equal to pi times the radius of the circle squared. And therefore, the area of this big circle must be equal to pi times the radius of the big circle squared. The radius of the big circle is 10, and the radius squared is 10 squared. So total, the area of the big circle must be equal to pi times 10 squared. 10 squared is 100, so in total this expression equals to 100 pi. 100 pi is 314.159. So we shall find out that the area that we are looking for in this question, that is the area of this big circle, is equal to either 100 pi square units, or in terms of numbers, the area of this big circle is equal to 314.159 square units. Okay, thank you very much.